In today's video, we will discuss the concept of partial derivative. So far, we have been dealing with simple derivative, where we find the derivative of a function which has only one independent variable. Given a function y equals f of x, where y is the dependent variable and x is the independent variable, when the independent variable changes from the initial value x subscript 0 to a new value x subscript 1, the change is measured by the difference x subscript 1 minus x subscript 0, which is denoted by del x. Now the difference quotient delta y by delta x, which is the change in y to the change in x, measures the average rate of change of y. The derivative of y with respect to x at a point x subscript 0 is defined to be the limit of the ratio of the change in y to the change in x, that is, limit of the difference quotient delta y by delta x as delta x tends to 0, or limit of the ratio of the change in y to the change in x as delta x tends to 0. We know that the two common ways of writing notation for the derivative of y with respect to x are either as dy by dx or as f prime x. Dy by dx, that is derivative of y with respect to x, or f prime x, is equal to the limit of the difference quotient delta y by delta x as delta x tends to 0. So this is the simple derivative of a function which has only one independent variable. Now let us consider a function of several independent variables. Y is a function of several independent variables such as x subscript 1, x subscript 2 and so on, which are all independent of one another so that each can vary by itself without affecting the others, which implies that a change in an independent variable, say x1, does not have any effect on other independent variables such as x2, x3 and so on. Let us assume that variable x1 undergoes a change by delta x1 while other independent variables such as x2, x3 and so on all remain fixed. There will be a corresponding change in y, namely delta y. The difference quotient in this case can be expressed as delta y by delta x subscript 1, which is the ratio of the change in y to the change in delta x subscript 1. In the difference quotient, we can see that y changes due to change in the independent variable x1 alone, while holding all other independent variables constant. If we take the limit of delta y by delta x1 as delta x1 tends to 0, the limit will constitute a derivative. The derivative is called the partial derivative of y with respect to x subscript 1, which indicate that all other independent variables in the function are held constant. The process of taking partial derivative is called partial differentiation. The two most common ways of writing notation for the partial derivative of y with respect to x1 are either as del y by del x1 or as f subscript x1, which is read as the partial derivative of y with respect to x1. F subscript x1 or del y by del x subscript 1, that is the partial derivative of y with respect to x1, is equal to the limit of the difference quotient delta y by delta x subscript 1 as delta x subscript 1 tends to 0. Similarly, if the variable x2 changes while holding all other independent variables constant, the partial derivative of y with respect to x subscript 2 is denoted by f subscript x2 or del y by del x subscript 2. Again, if we allow the independent variable x3 to change while holding all other independent variables constant, the partial derivative of y with respect to x3 is equal to f subscript x3 or del y by del x subscript 3. Let us consider a function of three independent variables u, v and w. If we allow the independent variables u to change while holding v and w constant, the partial derivative of y with respect to u is denoted by f subscript u or del y by del u. Similarly, if we allow v to change while holding u and w as constant, The partial derivative of y with respect to v is denoted by f subscript v or del y by del v. Again, if we allow independent variable w to change while holding u and v constant, the partial derivative of y with respect to w is denoted by f subscript w or del y by del w. Please remember that if y is a function of several independent variables, if we take the partial derivative of y with respect to a particular independent variable, the other independent variables in the function must be held constant. That is, they must be treated as constant. So if we take the partial derivative of y with respect to u, v and w are treated as constant. Again, if we take the partial derivative of y with respect to v, then u and w are treated as constant. Similarly, if we take the partial derivative of y with respect to w, then u and v are treated as constant.